Alright, let's look at question 4 from year 2008. It's a common test 2. The first part is curve sketching. So let us review some of the theory required. Okay, so first about turning point. At the turning point, you probably recall that dy dx is 0, and then the other thing is about, say, concave and convex, where inflection point occurs, especially non-horizontal inflection point. So when it's concave, means the dy dx is decreasing. So you tend to see that dy dx tends to be from positive gets more and more negative, and if it's convex, like in this case, so you find that dy dx tends to be getting more and more positive. At least it will increases its value from more negative to be less negative. So what does that mean? Let's tackle the turning point idea first. At turning point, this is a turning point here. So it means that if we were to sketch the f prime, the f prime would cut the x-axis here. So let's mark this. That's for sure. And at the inflection point, now obviously this is a concave followed by a convex. So before b, the value of the f prime is actually decreasing. So it gets more and more from positive, it gets more and more negative, for example. And after the point b, it gets more and more positive, or at least become less negative, now, as we shall see. So before a, the slope is positive, definitely. So but after a, the slope is negative. What does that mean? It means that it's going to cut from here, cross a, goes here, gets more and more negative, but at point b, it's going to do a U-turn. Let's say somewhere here. So if we know that all this information using the theory that we know, so the curve going to look like this, cut, and then it's going to do a U-turn, and after this it's going to be the dy dx, or the f prime, is increasing. So it means that it's going to do this. But because if you notice that here, after b, the slope tends to be negative in nature, the slope, so it will still remain below the x-axis but tends to be 0. So that would be your f prime. Now moving on, we delete this. Okay, get a pen on. So now the second part, we need to answer some motion in a straight line questions. So part 1 of this, show this velocity function is as given as this. I mean, we just show that it's equivalent to this. So we start with finding ds dt, which is of course is v, and this is a quotient you see here. So this is t square, the v square, and this is v 3 1 over 3. This is of course the u minus it's going to be 1 plus 3 ln t times 2t. Alright, and I can simplify this because t can't be 0 otherwise, so meaning this is t to the power 4, okay, and therefore you can simplify all this, and you end up with t power 3 as your denominator, and this is 3, and this is within brackets 3 ln t. You have a 2 here, and if you simplify this, you will get as what requires this ln t t power 3 as shown. So the second part is find the exact time when object reverses its direction of motion. So that means well, you might recall from some of our video that means when it reverses its direction, it tends to stop momentarily, and that means when v is 0. So we're going to solve this equation, and of course the denominator can't be 0, so the focus will be on the numerator being 0 and this one. And be careful, but this is the exact time, so you cannot use a calculator in this manner. I mean, this question. So this is what is required: e to power 1/6. So let's move on to part 3 and 4. So find the time when the velocity of the object is increasing at the fastest rate. So we have v equal to 1 minus 6 ln t. So what we're going to do is, well, let's talk about what does this mean. So this means that if we going to find the dv dt is going to be the maximum. So so we're going to derive this one more time, and then need to find its maximum point, and that would be the solution to part 3. So the first part we're going to do it algebraically, and second part we're going to use the calculator to help us. Okay. More space here. 3t squared. Now I can simplify this again. It's t squared, and this is actually t to the power of 6, and a common factor. -6 minus, if I expand this, we get -3 and plus 18 ln t, and this is t to the power of 4, or I mean 9. So we are going to punch into the calculator and ask the calculator to help us. So let me call out my GC. Okay, so I'm going to enter this. Okay, the function is -9 plus 18. Well, we of course can solve this by hand, but it is actually quite difficult, and in the question itself it did not restrict you from using GC, so why not, right? So let's set the window first, from 0.5 to 4, and I suspect this will be sufficient. From -5 to 3, let's try something smaller. Okay, let's draw this. Okay, so you can see there's probably a minimum here, I mean a maximum here. So using calculator, get a maximum. Let's wait for it. So the answer is 2.11 or 2.12. So therefore, from GC, V is increasing at the fastest rate when t equals to 0.117. So finally, find the total distance traveled by the object from t equals 2 to 4 seconds. Now you might recall that from here there's t equals to e to the power 1 over 6. This is when the object reverses its direction, and if you calculate this, its value is I think would be, let me call the calculator again. Okay, calculator. So we're trying to calculate e to the power of ln e to the power of 1 over 6. So it's 1.18 and it's less than 2. That means when the object reverses its direction, it's only once when time is roughly 1.18 second. So this second this part 4 where you asked to find the distance travel will not be affected from t2 to 4. So all we have to do is just calculate as t2, okay, and then calculate as 4, and then the distance travel would be s4 minus s2. Well, the absolute of it, because it could be negative, and I leave the answer as it is. I will give the final answer, and it should be 0.448 in give and take.